Thank you very much to the organisers for inviting me to speak today. Today I'm going to present to you the results of a trial of an indicator tool called the Legate, which I designed during my PhD research at the Dublin Institute of Technology, now known as TU Dublin. The Legate is installed at a number of national monument sites in Ireland, and that was partially funded by the 2011 Environment Fund from the then Department of Arts, Heritage and the Gaeltacht. I'm going to give you a little bit of background to the topic, then talk about the pilot design, the implementation and results, and finally a few words on where to go next. So we're all becoming more familiar with what the impacts of climate change may be on heritage. These can be divided between direct and indirect effects. And the direct effects are often further subdivided between catastrophic sudden onset events, such as flooding or wildfires, and cumulative or slow onset events. And it's this latter that the Legate focused on. So the research question which led to the design of the Legate was, how can we understand the effect of climate change on natural, already occurring weathering processes that affect heritage? So here weathering is understood as one of those cumulative slow onset effects. And of course, there are many types of weathering that occur. They're seen as long-term effects, widespread but not highly visible, and therefore potentially can be overlooked. And climate change is likely to affect both the nature and the rate of the existing weathering processes. So the Legate focuses on weathering of stone, both surface and near surface effects. And the climate change projections for Ireland suggest that there will be an alteration and an increase in some cases of salt weathering, surface recession, biological growth, and wetting and drying stresses that affect stone. The good news is that we expect a reduction in freeze-thaw weathering events. So in order to understand how weathering processes are changing, we need monitoring at sites. And of course, because we're trying to relate this to climate change, we need that to be long-term, and the climate norm is approximately 30 years. But when I came to talk to people who work in this area or professionals on sites, a number of barriers were raised to creating long-term monitoring projects. The first of these was short-termism. So many research projects are short-term. They follow a 3 to 5 year funding cycle, and they often involve people who come for the project and go away again. And so they're not embedded at the sites. Where sites have created monitoring systems which they intend to be long-term, these can falter due to lack of systems that create institutional memory. So they might rely on one person, for example, who then leaves, and the whole project falls apart. Other issues are equipment failure, equipment maintenance and replacement costs, and software obsolescence. So in some cases, data was available, but people could no longer access it because they didn't have access to the right software, or the software was obsolete. So the design of the Legate then sought to address these issues using two kind of key concepts. And the first is the concept of indicators. Indicators are quantifiable variables that have an established functional relationship with the issue that you're trying to measure, and can therefore be used as proxies. So for climate change, natural heritage use a number of indicators, for example, the return of certain migrating species. Another informing concept was that of dosimeters. So dosimeters are devices that demonstrate exposure to a hazard, often because they're more sensitive to that hazard. So good example of a dosimeter is the the canary in the coal mine. So, of course, the trial was also informed by existing stone weathering research, and there is an established practice of exposing fresh stone in real-world environments in order to understand rates of erosion. But most of these studies have focused on pollution, and a lot of them also have focused on short-term exposures. So the aim then of the Legate was to create an indicator tool that was capable of signposting the nature of surface weathering of stone at heritage sites in Ireland, and whether those effects were altering over time with changes in the climate. So the Legacy Indicator Tool, or Legate for stone recession, is composed of a stainless steel, high-grade stainless steel plate with 5 cubes of 50 millimeters, which are attached to it using a nut and bolt system, so they're entirely demountable. All the plates have 4 cubes in common, that is a Peakmore sandstone, a Portland limestone, a concrete and a historic brick. And then at each site, there's a site-specific stone. So at Skellig Michael, for example, the 5th stone is Old Red Sandstone, which is the stone at the site. So the cubes are measured using a variety of both high-tech and low-tech measuring techniques. And this is another way of trying to address the sustainability of the indicator. So they were measured before exposure, and then the idea is that they're measured approximately every 5 years thereafter, and then returned to the site for further exposure. So in terms of implementation and results then, the Legate is currently installed at 5 national monuments. There's 3 plates at each monument, so that's a total of 225 cubes, which are currently out there weathering. And I have a series of comparative measurements. The last ones were taken in 2016. So there should be more measurements taken in 2021. So these are the sites that the Legate is at. Brúnaboinne and Skellig Michael, which are Ireland's 2 World Heritage Sites, also an urban site at Dublin Castle, and 2 Midland sites, Clonmacnoise and Rock of Cashel. The great thing about Clonmacnoise is that they actually also have a weather station on the site. For the other sites, I had to take climate data from the nearest meteorological station managed by Met Éireann, which doesn't always give you the most accurate sort of site-based data. So this slide shows you a couple of images of Legate in situ. The exact positioning of the plates was negotiated with the conservation architect for each site. So you can see at Clonmacnoise, the 3 plates were put together in a service area that wasn't accessible to visitors. In Skellig Michael, the conservation architect was interested in microclimates. So the Legate, the 3 plates are spread out across the site at different locations. This is an example of the climate data for the period of exposure up to 2016. The main thing to note here is how much more extreme the climate is in Skellig Michael, that's the blue, than the other sites. So you can see almost twice as much rainfall. There isn't wind data available for all of the sites, but again, you can see it's much windier than Dunsany, which is the Met station closest to Brúnaboinne. And that is borne out in the cubes themselves. So this is the surface roughness average measurements for the cubes. So you can see before exposure, the surface roughness is all fairly grouped together. And then after exposure, they've all increased in roughness, but the red dots, which represent Skellig Michael, are 2 or maybe even 3 times the increase in roughness to the other sites. And this is also borne out in looking at the visual evidence from the digital photographs. So you can see here on the left is a Portland cube from Brunner-Boyne, and on the right, a cube from Skellig-Michael. And so just visually, you can see how much rougher that cube is. Dimensional change, just taken with a handheld vernier caliper, so there is a margin of error here. But even given that, you can see that if you compare the top graph, which is Skellig-Michael, and the bottom graph, which is Brunner-Boyne, that the deviation from the original measurements is much greater for Skellig. So again, the severity of the climate and what we're seeing visually is also coming through in the measurements. Weight change is a strange one. I had really expected the cubes would lose weight, but in fact, most of them gained weight during exposure. Very small amounts, for most of them less than 1% weight gain, but probably due to biological growth or the uptake of salts from the atmosphere. So it remains to be seen how useful this is going forward. Color was also measured using the LAB scheme, where L is darkening, A is greening, and B is yellowing. So you can see from this graph that in most cases, darkening and greening, and in most cases, again, yellowing was seen on all cubes, but to a different degree depending on the site. But that also needs to be interpreted in relation to the visual. And so here you can see the difference between three sites. Clonmacnoise, which is number one, showed a lot of lichen growth in contrast to moderate lichen growth from Skellig, and then Brunner-Boyne, which was more algal. So you can see the difference here between the sites, but also you can see differences within sites. So this is an example of the information you can get on microclimates, where you see here Peakmore cubes from the Rock of Cashel, 2 different plates in 2 different locations, and very different biological growth occurring. So the problems encountered during the pilot trial included the loss of 2 cubes. One was stolen and one was accidentally broken. Delay in installation at Dublin Castle, which is why I didn't have any data from Dublin Castle to share with you. That was just miscommunication and staff change, and partly also because what we talked about earlier about researchers such as myself coming in from outside. Another issue was some small cracks started to appear around the fixing, so that's a design issue that could be addressed. And the inclusion of brick and concrete was done in order to try to make the Leggett have wider application, but actually it was very difficult to interpret the results for those cubes because the materials are so heterogeneous, and probably I would not include them in future iterations. So in conclusion then, the pilot trial of the Leggett proved its potential, I believe, as a long-term indicator for surface weathering. Simple modifications could be made, and I've mentioned a few of those in order to address the shortcomings that the pilot flagged up. And I think that comparing results over time at each site and between sites will help to build a picture of surface weathering and heritage sites across Ireland and how that is relating to measured climatic change. So thank you very much for your attention. If you would like to know any more about this project, there are 2 open access articles published in Heritage Science, and please do ask me any questions. Thank you.